Welcome. Today we're going to talk about energy and different forms of energy, and I'm going to give you some examples. We're going to be able to identify different types of energies being used in situations, and then we have a lab that will be doing this on also. So here's my matrix on energy, and we'll just go ahead and go through it. So energies. And there are numerous types of energies. You have the first one I want to talk about is nuclear energy. Enduring nuclear energy is energy caused by the splitting or combining of atom nuclei. And so nuclear comes from the idea of nucleus. And then you have fusion, which is where we combine very light atoms such as hydrogen and helium and carbon to form heavier elements. And then you have fission, where we have really heavy elements such as plutonium or uranium. We actually split it to get energy and to create newer elements or lighter elements as we go along. The one that we do now, we're able to successfully complete fission. Fusion, on the other hand, is hard to complete, and it's only right now carried out in stars. The next type of energy is electromagnetic. In this kind of energy, we have radio waves, ultraviolet waves, the electromagnetic spectrum, but we also have energy stored in what's called electric fields, and that's where we get electricity from. We also have magnetic fields, which is caused by electricity, but we won't get into that. But just electricity comes from electromagnetic. Now let's talk about the thermal. Thermal is nothing more than heat energy. It's the most abundant type of energy that we have in the universe. And eventually all energy turns into heat energy. And once we get to heat energy, we lose the majority of our energy. We can't get it back. We can't reharness it to do anything else. Chemical energy. We use chemical energy every day. The food that you eat is your chemical energy. The gasoline your car takes is chemical energy. The batteries in your MP3 player or your iPod use chemical energy, and those are caused by chemical bonds between different elements, and then it's the breaking of those bonds and recombining of those bonds. Mechanical energy. Now this is the one that actually we are going to study in this unit, and this is broken down into two different types of energies. You have the kinetic energy, which is energy of motion, and we'll talk more about how we calculate that and stuff as we go along in the next video. But there's two types of kinetic energy. You have what's called translational, which is linear or straight line, where you have an object that's actually moving forward, and it can move forward and turn and everything, but it just has to move forward. And then the other one is rotational, where you actually have an object spinning. So translational would be like your car driving down the road. Even though it can still turn and stuff, it's not spinning while it's going down the road. Whereas rotational is more along the lines of the Earth spinning on its axis, or a top spinning, or if you want to go down to the molecular level, an electron spin. The other type of energy, of mechanical energy, is potential energy. And potential energy is just that. It has the potential to move or to do some kind of work. And there's two types that we are going to talk about, and we'll actually talk about and calculate both of these. You have gravitational potential energy, and can anybody guess what gravitational potential energy deals with? Anybody? Okay, well, see how nobody guessed. Gravitational potential energy deals with gravity and being inside of a gravitational field. So it's what kind of energy can the Earth do to you, or do to an object that's on the surface. The other one is elastic, which is due to the deformation of an object. And this is like a spring or a bouncy ball or an elastic waistband. Whenever you pull or you stretch or you compress, you actually deform it, and this stores some form of energy. Right. And then the last one, which was found by Einstein or proven by Einstein, is mass. And we can actually convert mass into energy, and energy converts back into mass. And we see this in numerous experiments, and the large colliders that we have, we can actually cause particles to come out of energy. And so let's look at some different or some normal everyday situations and compare the energies that we see in these. And so let's look at the light bulb. So we have a light bulb, and can anybody tell me some of the energies involved with this? All right, the first one that we should talk about is electromagnetic. It's light. Light is electromagnetic, but not to mention the electricity that flows through the wires to cause the light bulb to light. Also, it falls under this electromagnetic energy. But we also get thermal, because how many people have ever reached up and touched a light bulb that's been on for a while? It gets hot, and so you have this thermal energy. All right, let's look at this one. This is an engine. An engine utilizes multiple types of energies, and we're only going to go to the part of the energies that cause your car to go. I don't really care about, I don't want to look at the energies that where your car is getting electricity for the radio or to start or your windshield wipers. Instead, let's look at what the engine does. It moves your car. And so it starts off with chemical energy in the form of gasoline, and then it causes that chemical energy to combust causing thermal energy. And then that thermal energy causes the air inside the cylinders to expand, and you get mechanical energy where it pushes the piston down and then causes the tires to rotate, and your car goes down the road. Here's one. I want to look at the nuclear power plant itself. The nuclear power plant inside has uranium, and whenever you put enough uranium together, it causes it to fission, which is split apart. And so whenever we put enough uranium together, we get a critical mass, and then it splits apart, and we get energy out of that. So nuclear power plants do fission, and there's still controversy on whether or not that is an adequate or a reliable or for a good power source, because there is radioactive waste at the end, but you get a lot of power for little resources, and we're kind of using up the resources that we have now. So fission is what we do, and there's still debate on whether or not it is good for us. And then the last one, we have a pot of boiling water, and if you notice, it's sitting on an electric stove, so we're going to go ahead and say that it has some kind of electric energy or electromagnetic energy, and then thermal energy where it heats up the coils of the stove, and then once the thermal energy heats up the water, you get mechanical energy where it actually causes the water vapor to rise through the bottom of from the bottom of the pan and then out through the top and rise up into the air. And so that is all the different types of energies. The ones that we're really going to focus on are kinetic and potential energies, and it's going to be in the realm of the mechanical energies. And on the next video, we will explain what those are.